Currently, there is a cosmic time bomb ticking calmly approximately 650 light-years away from us. This is no ordinary bomb. If it explodes, it will unleash a fiery tsunami across our Milky Way galaxy, shattering any planets in its path, transforming their surfaces into magma, stripping away their atmospheres, and spewing waves of radiation and matter. The truly crazy part? This bomb is quite close to our galaxy. You just need to look up at the night sky. Yes, this star is one of the most luminous, most orange-red, most eye-catching stars you can see in the sky. That large dot on the left side of the Orion constellation. Yes, it is none other than Betelgeuse, the nearest red supergiant to us. Analysis by some scientists points towards it going supernova soon. But what does soon mean in astronomical terms? That is the critical question here. How much time do we have? Centuries? Years? Or even sooner? And what does this terrifying-looking explosion mean for us tiny creatures on Earth? Scientists seeking the answer to this question are standing right on the precipice of this massive, variable star's potential demise. And as time passes, as Betelgeuse's countdown progresses, new surprises may await us. I am Jackie, and you are watching GCO. Join our channel today, and let's examine together everything we know about Betelgeuse and the incredible new mysteries and discoveries about space. So let's dive deeper. As always, let's get to the root of the matter. Betelgeuse is one of the top 10 brightest and most luminous stars we can see in space. It sits on the left side of the Orion constellation, making it quite easy to spot and identify. If you go outside at night and look up at the sky, you will observe that it appears redder than the other stars around it and twinkles intensely. This color suits its nature perfectly. Betelgeuse is a full-fledged red supergiant, essentially a mid-mass star in its final death throes. Its flame-like color stems from this. This monstrous star is much, much larger than our Sun. In fact, Betelgeuse's radius alone is nearly 900 times larger than the Sun's and extends out towards Mars's orbit. However, its mass is only about 10 times greater. This means it's as soft and low density as cotton candy. Its gravity is quite weak, struggling to hold its own matter together. That is why we observe its surface boiling with massive bubbles. Just imagine watching a dangerous sunset on this star. Of course, the most intriguing aspect is Betelgeuse's impending end. Supernova explosions do not occur very frequently in our galaxy. Scientists observe hundreds of them outside our galaxy every year. Imagine how crowded the universe is. In our own neighborhood, the Milky Way, we see only about 2 or 3 per century. What if such an explosion occurred? How would it affect our galaxy? The answer is simple. It all depends on distance. The interesting part is that, according to scientists, Earth has likely been adversely affected by a supernova before during its estimated 4.5 billion year lifetime. What we need to know is that we reside in a bubble-like region of space. This bubble, this area, was likely carved out by the death of a supernova explosion some 10 to 20 million years ago, a rather empty region about 1,000 light-years across. Our planet experienced that explosion long ago. Evidence of another explosion, estimated to have occurred about 2.5 million years ago, was confirmed by finding excessive amounts of iron, 60 isotopes in geological layers. More intriguingly, some scientists suggest that the extinction of woolly mammoths may have been caused by debris from a supernova explosion striking Earth approximately 13,000 years ago. Magnetic particles found at the impact site and radioactive potassium, 40 from supernova debris, are strong evidence for this. Even mammoth tusks from about 34,000 years ago have been found with small craters caused by radioactive iron fragments traveling at 10,000 kilometers per second, the exact speed of supernova debris. This must have been quite an unpleasant experience for the mammoths. So, what have we realized at this point? As hypothesized, if life on Earth began around 3.7 billion years ago, and looking at the evidence from the last 20 million years suggesting at least 3 supernovae have affected us, and we are still alive and thriving in this galaxy, then perhaps these supernovae are not the absolute annihilators we've been describing from the beginning? Yes, I think so. The crucial factor is the proximity of the potential explosion. Suppose a bomb is 1,000 kilometers away from me, there's nothing to fear. But if it explodes next to my house, then the outcome changes. So where and how this supernova explodes in the universe, and its distance from Earth is significant. We can only grasp the power of a supernova by understanding the process that births it. Of course, regarding this potential explosion brewing within Betelgeuse's layers, it seems there are two main scenarios for how such an event occurs. Scenario 1. Type Ia supernova. This is the story of a white dwarf in a binary system. This dense stellar corpse slowly or rapidly steals matter from its companion star. The theft continues until the white dwarf reaches a critical mass. With this event, its internal balances are disrupted. The key feature of white dwarfs is the perfect balance between the resistance created by compressed electrons and the crushing gravity. However, as it gains mass from the stolen matter, its gravitational force increases, causing its entire structure to collapse. And within seconds, the star's carbon undergoes fusion, transforming into heavier elements, releasing an immense amount of energy in the process. This released energy escapes in a few seconds, and the star's entire outer layer is ejected in all directions at nearly 6% the speed of light. It becomes a fireball layer with a brightness 5 billion times greater than our Sun. Scenario 2. Type 2 supernova, Betelgeuse's path. This is the process that all supergiant stars like Betelgeuse undergo at the end. These stars continue to burn internally by fusing hydrogen into helium in their cores. This burning creates an outward pressure that prevents the star from collapsing under its own gravity. But eventually, the fuel runs out. When hydrogen is depleted, helium, carbon, and oxygen all start burning together. These burnings inflate the star like a balloon, turning it into a red supergiant. This continues until iron forms at its core. The real problem starts here. Iron does not produce energy through fusion, it consumes it. The fusion engine stalls. With the outward pressure gone, the entire weight of the star falls onto the core, which no longer has the strength to resist. This collapse is so violent that it rebounds, causing an explosion that blasts the star's outer layers into space. All that remains is a neutron star or a black hole. So, what is the risk level for Earth? Our Sun is too small to compare or transform into a supernova, so we can breathe a bit easier. If it were to happen, our Earth would likely vaporize and disappear. What's surprising is that the effect of the explosion diminishes incredibly rapidly with distance. Scientists have calculated that even a planet at 100 times the Earth-Sun distance, while its atmosphere might survive, would not be enough to prevent it from being torn from its orbit and flung into space. This means all life forms on that planet would freeze. The real threat is the high-energy radiation hurled out after the explosion. This radiation disrupts our atmospheric balance, depleting or even destroying the ozone layer. These events would affect and destroy the basic food chain in the oceans, leading to mass extinction. Experts estimate this kill zone for a supernova to be about 500 light-years. For now, this means we only see it as an incredibly bright star in the sky. Yes, we can breathe a sigh of relief. Betelgeuse is 650 light-years away, and we are safe. Are there any candidate stars within 300 light-years likely to go supernova? The answer from experts is no. Betelgeuse and another giant, Antares, are currently the nearest known candidates, and fortunately, they are both over 400 light-years away. Another risk, white dwarfs, could be more dangerous. But thanks to the Hubble Space Telescope's mapping of this risk, we have detected thousands around us, and none currently appear to pose an explosion threat. Of course, near in this context actually means the near future, like the next hundreds of thousands of years. According to expert analysis, when Betelgeuse explodes, the heat wave reaching Earth will be weaker than the solar wind from the Sun. The Sun's magnetic shield will protect us. Its impact on Earth will only be a spectacular light show in the sky, as bright as the full moon, easily visible even in daylight. Just imagine for a moment, looking up at the sky and watching a star die. Truly fantastic. Let's come to the biggest question. But when? Yes, the supernova named Betelgeuse will explode soon. But in space-time terms, soon can mean a period up to 100,000 years. However, some experts, based on recent analyses, suggest that this red supergiant star could potentially explode within the next 10,000 years. The reason for this speculation is that this star might be even more massive than thought and could be aging much faster. The star Betelgeuse does not easily share its mysteries and secrets with us. According to recent studies, it seems to be playing games with us. Its brightness unpredictably dims and brightens in cycles not fully understood. Observations in 2009 detected a 15% shrinkage in its size. Then in 2019, the Great Dimming occurred. Its light diminished so much that everyone panicked, thinking it's here. But it turned out the star had hidden itself behind a massive dust cloud ejected from its atmosphere. The Hubble Space Telescope, monitoring this star, observed the hot material cooling, its distance, and how it blocked its own light. By April 2020, we observed Betelgeuse returning to its former brightness. The dust cloud obscuring it had dispersed. However, this event drew even more attention from the scientific world. And then an incredible discovery was made. For centuries, there was a question we sought an answer to. Could Betelgeuse not be alone? Was a companion star orbiting it? Betelgeuse's turbulent, unstable surface made detecting such an object incredibly difficult. Until after the 2019 dimming, when scientists from two different units independently reached the same conclusion. Betelgeuse's longest brightness cycle of 2,170 days could only be explained by the presence of a companion star. They named this tiny companion beetle buddy, or its official name, Sawara. The Large Gemini North Telescope in Hawaii, through a special study, finally managed to capture a photo of it, albeit not perfectly clear. This companion star's light is about 6 times fainter than Betelgeuse's. This discovery proved that this long cycle was not related to an imminent explosion, but was an effect caused by the companion star. This indicates to us that Betelgeuse's explosion is still far off. Perhaps we won't witness it. Another crazy mystery: its rotation speed and acceleration. Data from the ALMA telescope revealed that Betelgeuse's surface layer is rotating at a speed of 5 kilometers per second. This speed literally defies the laws of physics for a red supergiant. If our sun were that expanded, its rotation speed would drop to millimeters per second. So how is this possible? Theory 1. Stellar cannibalism. Perhaps Betelgeuse swallowed its companion beetle buddy, or is slowly swallowing it, and acquired its rotational energy to achieve this high speed. Theory 2. A grand optical illusion. A newly assigned research team suggests that what ALMA observed might not be the star's rotation, but the movement of the massive, chaotic bubbles around it. Each of these visible bubbles is 100 million kilometers wide, rising towards us and receding, creating blue and red shifts in the emitted light. Due to the telescope's limited resolution, these erratic movements might appear to us as a smooth rotational motion. Perhaps, contrary to our estimates, Betelgeuse isn't rotating fast at all. So which theory could be correct? The answer will come from telescopes with higher resolution and their data analyses. In conclusion, this is the mystery-filled story of Betelgeuse, a trembling giant supernova nearing its end, whispering its secrets to us only rarely. Humanity's fascination and admiration for its grand and mysterious end, for its explosion, continues. The moment Betelgeuse explodes, it will be a universal fire and light show. And this event will reveal some of the deepest, most hidden secrets of supernovae to us. For now, the most important thing known is, it will explode one day. And we humans on Earth, from our safe zone, will watch the final death throes of this cosmic dance. I hope we all get to see that moment. Now I want to ask you, which theory do you think is correct? A cannibal star or a grand illusion? And most importantly, would you want to see it explode?